Greetings everyone, my name is Sami Madundo from the group Conservation, coming from Sokoine University of Agriculture in Morogoro. With me are my group members, Chloe Kisaka, Mandela Lolila, George Guyonjo, and Masha Pandu. Our title of the data visualization is Carbon Sequestration to Address Urbanization. Coming to the second slide, we have our data visualization solution. And the problem we are addressing is the rate of urbanization. Dar es Salaam is a growing city with a growing population. This means that infrastructure is being built, vehicles are being brought into the area, and the activities done result into emissions of carbon and carbon dioxide, which we know that it causes global warming and therefore climate change. And the negative impacts of climate change, of course, are negative. And so our solution to this is to present a visualization that is able to identify places in Mikocheni where we can plant trees that are then able to absorb this carbon dioxide and store it as carbon in the tissue of the trees themselves. The aim of this is to make Mikocheni a more climate resilient and low carbon economy, and having additional benefits of having additional social economic benefits. The target group will be the local community and the government itself, as well as NGOs, non-governmental organizations, and the decision makers, which are the urban planners and foresters. We now come to the data and methods that we used for our visualization. The data sets involved the pilot tree data in Dar es Salaam, consisting of 500 trees. We had the Dar es Salaam administrative subwards, particularly that of Mikocheni. We had the Dar es Salaam buildings, as well as the Dar es Salaam roads layer. The tools and analysis that we used were all from QGIS. These are all inbuilt tools. The first one was the open field calculator. Within our data set, we had diameter of each tree, which we were then able to convert to above ground biomass. And then that was converted to carbon. And finally, carbon was converted to carbon dioxide, all in kilograms. And we were then able to visualize this using the graduated symbology, again from QGIS, that you will see soon in the visualization. And then finally, to show the spatial distribution of above ground biomass in Mikocheni, we interpolated the values of above ground biomass using the linear interpolation tool, again in QGIS. So this is our first visualization, which is a static map of Mikocheni with the 500 trees distributed. And on top of each tree, you have a circle or a bubble that represents the amount of carbon dioxide that has been removed from the atmosphere. And so large trees would have removed more carbon dioxide and stored it as carbon in the trees. Smaller trees will have removed less carbon dioxide and stored it as carbon in the trees. And so each tree was then grouped into 3 classes, either low, medium, and high, based on the amount of carbon that it has stored. The next visualization is the animation that shows how the carbon dioxide is moving out of the atmosphere and going into the trees. And then finally, we have our third visualization, which shows the distribution of above ground biomass throughout the Mikocheni subward. It also shows the roads and buildings throughout the area. And this is important because now we can identify areas that have high biomass in terms of tons and areas that have intermediate all the way to low. The idea is that the idea is to get uniform distribution of above ground biomass throughout the area, and that means we have to identify places of low above ground biomass and plant trees densely or uniform throughout the area. So this map helps us identify where exactly we should go to plant trees and therefore increase the removal of carbon dioxide and sequester it into trees. We now come to our reflection, which is the last slide. And here we identified a few challenges during the visualization, which was that the data itself had missing values for diameter and also the names of species were not available, we could have shown visually the distribution of different species, but we're not able to. An important lesson that we learned is that urbanization and tree planting should go hand in hand. That means it should go together, and that we cannot just say that let us plant trees or let us just go for building infrastructure. We must put these together. If we're going to increase infrastructure, then we must also plant trees so that we can remove carbon from the atmosphere. Our work, of course, could be continued by working with the necessary stakeholders that we mentioned before, the NGOs, local governments, and decision makers, to make policies and therefore integrate our work with policies. For example, households may be required to have certain amount of area to plant trees. We can also provide extension services or work with extension officers, and also collaborate with decision makers in their decision making. And this brings us to the end of our visualization. Thank you very much.